Okay, so hopefully this is recording. Hi everyone, this is just a short video that I promised regarding the essay questions that you've got for your first assignment. There are three questions. The first is about explanation and causal interactions. The second is on the problem of induction, can it be solved? And the third is on laws of nature. So we're just going to go through each one, and I'm going to talk just a little bit about what you might write about, what I expect to see, and maybe just a little bit of explanation of what I mean by the questions themselves. So the first question, what is the best explanation for causal interactions? Okay, well, first of all, I think it's always a good idea to use examples. Sometimes it's useful to use the same example throughout. Sometimes you might find that different examples work better for different points you're going to make. But the first thing you're going to have to do is explain what you mean by a causal interaction. So we did all that work on Hume and regularity theories of causation and counterfactual theories of causation. We talked a little bit about Mackey. We even talked about dispositions. And so maybe the first thing you need to do is give a little outline of what you mean by a causal interaction, and in particular focus on events. So things like window smashing when the brick hits it. Okay, so once you've done that and you've talked about regularities, you've talked about counterfactuals and how one demarcates non-causal regularities from causal regularities, and so on. Then you want to talk a little bit about explanation. So what counts as a good explanation? Maybe you have to go and do some research on this. There's a fair amount of literature, but I suggest you start with the Stanford Encyclopedia entry on explanation, which is excellent. And what you'll find is that there are different kinds of explanation. So you will have causal explanations. So if you're trying to explain the event, the window smashing, you might explain it using the cause. So you say, well, the brick hitting the window caused the window to smash, and so the explanation is the brick hitting the window. Or you might say that the best explanation is a gnomic one. That is to say, an explanation that comes from the laws of nature. So in this case, you'll be looking at something that's called the deductive nomological model of explanation. So go online and do some research on that. But the general idea is that given the events that precede the cause-effect kind of interaction, and given the laws of nature, that event, the effect event was going to happen. It doesn't necessarily have to be as a matter of necessity. It's just a matter of explaining the smashing of the window in this case. So we'd be saying, well, the law of gravity and so on, in conjunction with the brick flying through the air, that explains the window smashing. Okay, so you're looking at causal explanations and you're looking at gnomic explanations. Well, then what? Okay, well, you might want to think about the metaphysics of it. So if you want to give a causal explanation, does the Humean conception of causation really provide you with a good enough, really provide you with a genuine explanation? I mean, if causation is just a matter of regularity, then can regularities, pure regularities, such as every time a brick hits the window smashes, can that really serve as a good explanation? Does the fact that all swans are white explain why this particular swan is white? It just seems to be a universal generalization, one part of which is the event, or in this case the color of the swan that we're trying to explain. So how can the event or particular situation that we're trying to explain be explained by something that includes that event? It doesn't seem to make sense. So I think a good place to read on this, if you go to, or if you can't find it, I'll find it for you. Stephen Mumford's book, Laws in Nature. The opening chapters on that are very good. I think it is the first chapter where we'll talk about Humean conceptions of laws and explanation. So yeah, have a think about whether regularities can have explanatory value. I have written on this elsewhere, and if you want direction, I'm very happy to guide you. Personally, I think that maybe regularities can. Maybe it's okay to say, that regularities have explanatory value. Maybe it's not. Okay, so you might need to do some research into that. If you're not happy with regularities having explanatory value, then maybe you need to look for some alternative causal explanation. Okay, one that involves necessary connections, the very kind of necessary connection that David Hume, as we saw, wants to deny. I can suggest that you go to you look up dispositional theories of causation. They talk about powers and how different objects they have powerful properties, and they dispose those objects to do certain things under certain circumstances. So the brick is disposed to smash the window when the brick flies through the air and hits the window. So you might want to look up dispositional properties. Alexander Bird's book on dispositions is really good on that. Let me think, what's it called? Nature's Metaphysics, yeah. So look up Nature's Metaphysics. Opening chapter on that will be sufficient. Alternatively, you can turn to David Armstrong's book, What is a Law of Nature? He has that view of laws as natural necessitation relations between universals, NFG, and maybe you can use that account as an explanatory account for causal interactions for those events. But now we're getting into the gnomic idea. So just as you can have Hume has a account of causation as instances of regularities, he has accounts of laws as regularities. And maybe those laws have the explanatory value. But again, you're going to have exactly the same problem. Can regularities really have explanatory value? David Armstrong says that laws are natural necessitation relations between universals. So there's some kind of metaphysical glue that links certain properties together. So you might have an electron that's, you've got this thing that's got the property of being an electron, and it's got a property of having charge -1. And in this world, those two properties are linked together as a matter of necessity. Contingent necessity, albeit, so there might be another possible world where those properties aren't actually glued together in this way. But in this particular world, there is this metaphysical glue that ensures that every time you've got an electron, it has to have charge -1. And maybe that law explains why electrons have charge -1. Now, using that kind of logic, you can then use the deductive nomological method and say, okay, well, the right explanations are the law-like explanations, and there's a metaphysics that underlies the laws that gives those explanations true explanatory force. Okay, so what we're trying to do is we're going to look at an event that we would normally associate with a cause-effect, so something like a brick hitting a window and a window smashing, or you can use Hume's examples of billiard balls and so on. You're going to look at a number of different kinds of explanation, primarily causal explanations and law-like explanations, gnomic explanations, and you're going to have a look at the metaphysics that underlies causal explanations, the metaphysics that underlies gnomic explanations, and see whether you take causal explanations to be the best or gnomic explanations to be the best, and which kind of metaphysics, which metaphysical underpinning you think provides the best explanatory value for those causal interactions, for the event of the window smashing. Okay, so that's the first one. Okay, so the second question, what is the problem of induction and can it be resolved? This question I've left intentionally quite broad. So we talked about enumerative induction, the traditional problem of induction, and that's it's just the one where you have a number of observations of past events. This one is white, this one is white, this one is white, and so on. And then you draw a general conclusion. For example, all swans are white, or you make a prediction about the future, such as the next swan I observe will be white. So that's enumerative induction. We also talked about Goodman's example, the new riddle of induction, and that's the GRU, where you have these gerrymandered predicates. In Goodman's case, an object is GRU if it is green and first observed before the year, say 3000, and blue if observed first observed thereafter. So that's the GRU problem of induction, the new riddle of induction. In this question, I've left it quite broad so that you can either focus entirely on the enumerative induction, on the traditional problem of induction, that you'll find associated with Hume, or you can focus on the new riddle of induction, the Goodman problem, or you can do both. Okay, so again, I expect a similar sort of structure. So first of all, I want you to outline what induction is, and this shouldn't take too long. I don't expect you to spend a huge amount of time outlining what induction actually is. And we're looking at it, remember, we're going to take a sort of a broad conception of induction. So we're going to take inductive arguments just to be non-deductive ones. Okay, so some people might want to, as I said previously, they might want to distinguish abduction from other forms of induction and say, oh well, no, induction is special in some way. No, we're going to take induction in this question just to mean non-deductive arguments. So what I want you to do first is to explain to me what an inductive argument is, full stop. And then you need to tell me what the problem is. Okay, so first of all, we've got what induction is. Then you need to tell me what the problem is. You can refer to Hume, or you don't have to. You can get your sources from elsewhere. Importantly, though, I need you to tell me what the key problem is with the problem of induction. Sure. Okay. And then after that, a selection of solutions. Now, a bit of advice: it's often best not to write down 8 solutions and provide kind of fairly brief explanations of each solution and then perhaps one criticism of that solution. That's not the best way to go about it. To get a really good mark, the best thing to do is to give a really detailed account of the solution that you choose. So you might think, for example, that I don't know, the probabilistic account, Reichenbach's probabilistic concept of inductive inference. That's the way one can solve the problem. In which case, pick on that one, use that one, and write as much about it as you can. Explain that solution in detail, and then find lots of sources that provide problems with that, and then maybe some solutions to those problems. And so on. So pick 1 or 2 solutions to the problem of induction, but don't try and cover them all, because that way you don't get the detail that I need to see in order to for you to demonstrate to me a really deep understanding of a problem and of its solution. Okay. Otherwise, it's just sort of it will just look like an undergraduate essay. But longer, and that's not what we're looking for at honours and masters level. I'm looking for a deeper understanding of a core concept, and that can just be one solution. It doesn't have to be all of them. Obviously, if you do both, if you try and cover both enumerative induction and the new riddle of induction in the same essay, then inevitably you're going to have sort of slightly more restricted space. So maybe you could cover 2 solutions if you did just simply the enumerative induction. Maybe you can only cover one solution for enumerative induction and one solution to the new riddle of induction if you try and cover both. Okay, so try and make sure that you don't get too ambitious insofar as you don't try and cover too many solutions in the same paper. You focus on one or two and go into a lot of detail. Okay, so there are a whole load of solutions. Most of them are in your core text, so I'm not going to go through them in detail now. But you're looking at the probabilistic one. You're looking at the inductive solution that ends up being circular, and so on. There's a whole load of. It's just. Falsificationism is one solution. It's in the book here. I meant to mention this purely because I want to advise not putting that forward as a solution to the problem of induction, even though it is in this book, because it's not really a solution to the problem of induction, right? It's a way of not using induction in science. So avoid falsificationism, but any of the other solutions are fine. So it's rational by definition. That's one possible solution. Let's see what else we put in here. Pragmatic solution, very happy for you to look into that one, and so on. Okay, just don't focus on falsificationism. It's not going to help you out. Right. Okay. So that's the second question. Make sure you outline induction. Make sure you choose before you start writing. Make sure you choose whether you're going to do just the traditional problem, just the new riddle, or both. And try not to be too ambitious. Don't cover too many solutions. Just focus on a few and do them in lots of detail. Show me that you really understand the core concepts, and show me whether you think they work. Okay. I don't want just a list of possible solutions. I want you to tell me whether or not they work. And why. Right, so third and final question, are there laws of nature, and if so, what is the best metaphysical view of laws, or something along those lines? So the first part, are there laws of nature, you might think is trivial. Say yes, of course there are. We talk about laws of nature all the time. That's fine, but some have argued that there aren't laws in nature, in particular, Stephen Mumford. So you need to read at least some of his book on laws in nature if you're going to focus on that. I don't actually mind if you write a very short answer to that. If you say, I'm going to assume that there are laws of nature because we talk about them all the time, or at least the fact that we talk about laws of nature all the time is a good indication that there are such things, or that we certainly have a concept of laws of nature or something along those lines, and it's just a matter of unpacking that concept. So it's okay to say, yes, we have a concept of laws of nature, even if you end up thinking that there's no necessary connections or anything like that. Okay. So I don't really mind if you don't dwell on that, but if you decide to go along Mumford's view of there not being laws, but all events being explained in terms of dispositional properties and that kind of thing, then I'm happy with that too. Really, what you're choosing between is a regularity account. So either sort of naive regularity account where something's a law if and only if it's a regularity. So all F's are G's is a law if and only if all F's are G's. That is to say, if F is electronhood and G is charge -1, all electrons have charge -1 is a law of nature, if and only if, in actual fact, all electrons do have charge -1. Okay, so that's a kind of naive regularity view, and then you're going to need to explain all the problems with that view. Highlight a load of the problems that we talked about in class. Single case uniformities, laws of no instances, for example, just a general inability to distinguish between accidental and genuine law-like regularities, and so on. Okay, so that might be your first task. Then you want to look at possible solutions to that regularity account. So David Lewis came along and said, okay, well, yeah, the best is this naive regularity view doesn't work, but we can actually fix it by introducing a best systems account. So you can go on and explain Lewis's best systems account and show how it solves some of the problems that you outlined in the previous section of your essay. And then you need to evaluate the best systems account. Now, some people think that that's great. Lots of people are still Humeans about laws, and they tend to accept Lewis's view or something like it. But you might think that those laws as regularities don't have explanatory value, they don't explain events, and that's what laws are supposed to do. So that account can't be right. So once you've evaluated Lewis's view, you need to talk about some others. So the Armstrong view that we've talked about that's relevant to causation, that is an account of laws of nature, ultimately, the natural necessitation relation between universals, NFG. So you need to outline his view of contingent necessitation, explain what is meant by contingent necessitation. That is to say, there's a metaphysical glue between two properties that holds in this world, right, or in a particular world, throughout the whole of time in this world, right? So in this world, those two properties are glued together by something that akin to necessary connection, whatever that might be. It glues those two properties together. But there might be other worlds where that doesn't hold. Okay. So yes, as I said previously in this video, it might be the case that in this world, all electrons or electron hood must be glued to charge -1 hood. Okay, those two properties must be glued together always. But there might be, and that is the case necessarily. There's this necessity that links these two things together here in our world. But there's another possible universe somewhere where all electrons have charge +1, and that's okay because the glue doesn't hold in that world, right? So there's that account, which you'll find in Armstrong's laws, What is a Law of Nature? And then you might want to talk about views of laws that come out of dispositional essentialism. That you'll get from Nature's Metaphysics. I think chapter 9. I'll have to look it up. I'll photocopy that now and put it on Blackboard. So you'll find a couple of chapters now. One from Mumford's book and one from Mumford's book and one from Alexander Bird's book for you to look through. And then once you've looked at the regularity theories and Armstrong's views of laws of natural necessitation relations and maybe something to do with dispositions, then you can assess them and decide which you find most plausible. The likelihood is you're going to say either regularity theories, that's an implausible conception of laws because laws have to explain things and mere regularities don't. There needs to be some kind of metaphysical glue, right? There needs to be something that ensures that objects drop to the floor when you let go of them, right? And the regularities, all objects drop to the floor when you drop them, that doesn't explain anything. Okay, there needs to be some kind of necessary connection. So you're either going to say, right, well, that can't be right, so Armstrong's view's got to be right, or maybe the dispositionalist view's got to be right. Or you're going to say, well, no, we can't accept Armstrong's view, which has got the metaphysical glue, because, as Hume argues, there's no meaningful concept of necessary connection. It's all very well calling something necessary connection, but as Lewis says, calling yourself Armstrong doesn't give you big biceps just because he's called it a natural necessitation relation, right? Doesn't actually provide us with a meaningful concept of necessary connection. It's just words. So maybe you might think, well, actually, even though it would be nice if we could provide something like an Armstrongian view that makes sense, all of those views are doomed to being meaningless, and so we have to accept some form of regularity account. And the naive view doesn't work because it's got all these counterexamples, so maybe we need to accept something like Lewis's. Okay, so you're going to have to make those assessments yourself and explain to me why you support the view that you do. Okay. If you have any questions, please don't hesitate to email me. This little video is fairly short. I don't go into any specifics on the views themselves, really. So if you're confused or you need a bit of help in any way, just feel free to email me on bsmarts@uj.ac.za. Okay. Good luck, everyone. I'm sure I'll hear from some of you shortly.